Hey, good evening and welcome to another episode of Challenges in the Street. I'm Battalion Chief Mark Davis. Happy to be here again with a third part of our series on fire protection systems with Chief Dempsey. Tonight going to talk about some sprinkler system stuff. Got a few things to take care of ahead of time prior to that. As usual, right, so any certified chief officer that would like to get COPDI credit, what we need you to do is sign in with your name and fire service ID, and then of course at the end of the presentation sign out doing the same. If you are watching it with a group of people, would be interested to know where you're watching the episode at and how many people are with you. That would be great. Questions, again, we've been doing the questions via the chat on YouTube, so please take care of any questions. We'll try to get to them as they come in. Captain Brady Miller is going to be moderating that this evening. And really, before we talk somewhat about sprinkler systems, we had teased a little bit in the last boss talk about 23's fire that they had. 23B shift had the fire on Montrose Road, the HVAC power plant stuff up on top of the roof. And one of the things that happened there was the sprinkler system. So a couple photos. So I go back to what we talked about before, right? So we have an incredible amount of buildings throughout Montgomery County, new and old, and they are only building more and more of these. We are fortunate in the county code in Montgomery County, right, that our buildings are pretty well protected. We still have a bunch that are not from way back when, and that'll come up in next month's boss talk. But, right, so think about going down to the road to this in 23's area, and there you know that you got a fire there, and that fire is reported on the roof, and this is going to involve standpipe operations. Pop to that next picture. Right, so that's pretty impressive. It doesn't matter what building that you go into. And of course, one of the issues that you may or may not have heard at is there was a failure of the standpipe system in this building. And so knowing that Chief Dempsey was going to talk about fire protection systems tonight, specifically sprinkler systems, we asked him to, hey, can you dig into the standpipe issue that occurred and at least provide some thoughts on what may have happened, and more importantly, what could be some workarounds here. I think every company that has standpipe buildings, you have to plan a workaround, like what am I going to do if my standpipe fails me? We don't have those on a frequent basis, but when they do happen, they're problematic, and that happened here. So that's all I really have. At the end, remember to sign back in if you're looking for credit, and right now we're going to turn it over to Chief Dempsey. Going to talk about the Montrose Road fire and then some sprinkler system stuff. Chief Dempsey.
Okay. All right. Thank you, Chief Davis, and thanks everybody for having me back. The timing of the fire on Montrose Road was kind of fortuitous for me, because what I want to do tonight is kind of get beyond the FDC. You know, we go to so many calls, sprinkler buildings, standpipe buildings. We tie to the FDC. The FDC does its job, and we're done. And what I wanted to deal with tonight is, okay, what do we do when that doesn't work? And that Montrose Road fire was a good example of what can happen. As it turns out, the fire was in a piece of HVAC equipment that was being dismantled. And in fact, it was the cutting torches that set the thing on fire. I talked to Captain Kinna about it, and funny enough, if we didn't have this water damage in the building, we likely would have had almost no fire damage, even though it looked pretty impressive from the street. They were very fortunate in the way things worked out, but I'm going to spend a little bit of time at the beginning talking about that specific incident, and then we'll talk about the workarounds, and I want to make sure we take time to answer questions. So if anybody has another idea of what a workaround could have been, we'll certainly accommodate that. Let's go ahead and go to my computer. All right, so I've gotten questions and phone calls from people following some of the other presentations. I wanted to make sure that everybody knows that they're more than welcome to contact me. My personal cell phone number is here, as well as my county email. You have questions and whatnot, don't hesitate to call me. All right, so this is our incident. On the left is what looks impressive. In the end, from a fire damage standpoint, really was not very impressive. They were taking that equipment off the roof anyway, and probably would have been in the thousands of dollars for damage. On the right, unfortunately, is what created a great deal of damage. And it had the potential to take an incident like this, if this had been on an occupied floor, and turn it into a chaotic potential disaster. What you're looking at with that much water, it wouldn't surprise me if that gets into $300,000-$400,000 in water damage. The only good thing is none of the actual units were damaged. The lower picture on the left kind of gives you an outline in the building. So what happened? There's been a lot of table talk about what could have happened, but what did happen was relatively simple. If you look at my arrow here, the red arrow, this is kind of diagrammatic of the building. The standpipe that 23's crew was using would be represented by this standpipe. There was another standpipe in kind of the middle stair, and there's actually another standpipe in a far left stair that I didn't show on here. What happened was a Victolic fitting gave way and broke apart on a 6-inch bulk feed main. Once that happened, all of the water, and so you're talking about a 6-inch opening that totally was open and flowing water, so there was no water in the standpipe used by Company 23 suddenly. Interesting enough, Captain Kinna said that as he entered the site, there's 3 fire department connections on site, and he had planned on using the fire department connection that would be close to the riser that they wound up using. He changed his mind at the last minute and used the standpipe connection, the FDC, that would have been more proximate to just coming in off of Montrose Road. When the fitting failed, they were able to pump a little bit higher, and they went to actually tank water and pumped and get water out of this standpipe, which I believe it was 3's crew had extended a line off of that standpipe. And that gave them enough water to mitigate the incident and finish. On the other hand, if this had broken here, shown by the blue arrow, you would have been done. You wouldn't have gotten any water from any of these standpipes. I'm quite certain of that. So we were a little bit fortuitous that it turned out the way it did. But what I really want to talk about is what the potential workaround would be. So option A would be to try to isolate your standpipe from the break, and all of the standpipes should have what's called a riser control valve. And that's represented by that valve just to the right of the arrow with the red in it. And what we would do is that's going to typically be found on a lower floor, first floor or maybe the first basement floor. It can be located in the stairs. It can be located just outside the stairs, but it should be pretty proximate to that riser that we want to control. Now in this case it was an older building, and they did not do any upgrades that made them put in pressure reducing fire hose valves. And in one of my other presentations we talked about those. So I think everybody's been trained to, kind of, if the FDC fails, you have the option of pumping into the riser, right? If you have a pressure reducing fire hose valve, you could pump all day long at unbelievable pressures. It is never, ever going to let water into that standpipe. It's not going to happen. The way that valve is designed, there's a spring that controls the pressure. It's going to basically see high pressure on the supply side of the valve, and it's going to shut itself down, assuming it has plenty of pressure. This building did not have pressure reducing fire hose valves. So you would have had the opportunity to isolate the standpipe and pump into the system through a or 2 fire hose valves. This stair was located at the edge of the building. The door to the stair opened directly outside. It would have been relatively easy to do. The toughest thing would have been finding that riser control valve. So the question has been brought up, well, what happened? Why did this happen? I know there's been discussion by some that maybe the pumper operator overcharged the system. Well, I can tell you definitively that is not the case. The fittings that came apart are rated for a working pressure of 300 psi. Well, when you say working pressure of 300 psi, they're probably tested to a pressure of 500 or 600 psi. I know the new pumper that Wheaton's buying, meets NFPA specs, and the maximum we're going to pump at is what, 250 psi at 50% of the rated capacity of the pumper, right? So if we have a street pressure, maybe best case scenario of 100 psi, maybe we can pump this thing at 350 and push 400 psi, but not realistically. I talked to the building engineer. I actually went to the site 2 times. The fitting was found to have the bolts, and this is the type of fitting it was. And see these bolts? The fitting was found that these bolts were not torqued to specifications. In fact, they were nearly just beyond hand tight. So how did this live for some period of time? This was a pipe that was put in when this building was renovated, I think some 8 or 9 years ago, if I'm not mistaken. So this sat for 8 or 9 years with these bolts loose. Well, it had a pressure test put on it, and that's fine, but a pressure test doesn't replicate the dynamic forces of actually flowing a lot of water. And what happened was we had enough dynamic forces, and it was a double elbow. So picture 2 of these elbows kind of mated to each other to change in elevation. It was a double elbow, so you're going to have your forces are going to kind of be multiplied as it goes through that double elbow, and it eventually gave up the ghost. So there's not a scenario I could come up with where the pumper operator made some mistake or something. It just wasn't the case. It was a fitting that sat for many years, and finally when it was called on to be used, it didn't work. In my investigations, I actually had a case in Wilmington at one of the bank buildings. A fitting at the top of a riser gave way. It had been there for 7 or 8 years. It gave way during a fire pump test, and it did $6 million of water damage. So that was significant. We actually went through that building and examined every single fitting in the building, and we found about 20% of the fittings were not torqued to spec. And that's obviously a problem. What we also found is, interesting enough, we could kind of track that lack of attention to detail to one sprinkler crew. They had 3 crews working, and we could kind of track one crew that didn't do their diligence in putting these fittings together. So they lived for a long time, but when they're called on with a dynamic force, they can definitely give way. Yes?
So we actually have 2 questions, Chief.
Yes.
One of them is from me. So you showed a picture of the riser control valves. Are those valves always going to be located between the pump and the riser? Is that where we look for them in buildings?
Yes. So your best bet to find them, your best bet is to go into the stairs, locate the standpipe riser, and then find a pipe that comes off the riser that's either the same size as the riser or bigger than the riser. That is your bulk feed main. Somewhere between either inside the stairs and outside the stairs, but in that vicinity will be a control valve that allows you to isolate that riser.
And are these on newer systems, or
no? That's
always been. So even in our older structures,
that's been in the code for a long time. What the idea is behind it is they didn't want to have a situation where if you had to do repairs on a riser and you couldn't isolate a riser, they didn't want those repairs to take down an entire system.
Okay.
So by having this isolation valve, it allows you to do repairs to a system, but it also provides us with redundancy in the system.
Very good. And question 2, how often are wet standpipe systems hydrostatically tested or tested?
Well, something like this, after day 1, they're not really ever hydrostatically tested again. Now, from day one, they would have done a rooftop flow test, and that would have been part of their initial test, but obviously that test did not cause that fitting to fail at that point. But after day one, they're not typically hydrostatically tested until work is done on them again, and then they're retested.
Thank you.
So the hydro test is primarily looking for small leaks, but it may not expose a catastrophic issue like this. It just might not. So I'm gonna draw on the board, and I'm gonna diagram this on the board as to what our first workaround really could have been. So we've got our riser here, and our fire hose valves, and we know our bulk feed main comes here, and we know we have a valve right here. Okay, and we knew that 23's crew, they were doing their thing and flowing water up here, and I think we're 17 stories if I remember correctly. They're doing their thing, and everything's just fine. And all of a sudden, our double elbow here goes, and this is, an open 6-inch line is probably flowing, I bet it's 1,200, 1,300 gallons of water a minute. There's no doubt. All of the pumper operators that were on hydrants at the time reported that their intake pressure dropped to 0 when this happened. Well, that happened because that fire pump all of a sudden was running to like infinity. And that fire pump was saying, ooh, I need all this water. So it grabbed as much water as it could, and that caused the street pressure to drop. The 23's pumper operator, thinking really fast, didn't know exactly what had happened, but he knew all of a sudden he had 0 suction pressure, so he switched to pump water. And that gave enough water to get it up and let 3 finish putting the fire out. So we would come in, we would close this valve, isolate the standpipe, bring in probably 3-inch lines are going to be best. Start by hitting one fire hose valve, charge it and then open it up. Get another one going, charge it and open it up. With the idea that what we want to try to do is replicate what this is designed to do, which is 500 GPM, right? So we might as well try to replicate that as much as possible because that's our safety factor. Likelihood of needing 500 GPM, pretty small in most of our fires we run, but we should try to shoot for that. So that's workaround one, but workaround one could have easily been made no-go if these had been pressure-reducing fire hose valves. Well, now you got to go to workaround number 2. So workaround number 2 is going to be a lengthy operation. Workaround number 2 is going to be you're going to build a standpipe, right? You're going to come back and build the standpipe. I talked to Chief Davis about this because, I don't necessarily live in the water squirting world all the time, or the ladder truck world. And Chief Davis said his first thought would be, well, if nothing else, let's make our job easier. And we got 17 stories we got to do. Instead of building 17 stories of hose line to replicate our standpipe, why don't we take one of our fancy dancy tower ladders and that could be the start of our flying standpipe. We would then work off of this and then stretch lines to the stairs and up. And at the very least, I think 23's guys told me that they had made the 9th floor. So at the very least, you'd probably pretty quickly get 9 floors of your standpipe built, and now you're going to, finish it out with hose. So the next thing that people should think about is, again, if you're going to take the time to build it, you want to build it enough to get the water you think you may need, right? I know everybody's heard about the One Meridian fire, and one of the issues they had is they had to build a significant standpipe, and it took a significant amount of manpower and time, and I understand that. So doing some real quick calculations, in my opinion, the thing to do, I think LDH hose is unreasonable. to use in this case. So I think the compromise would be to go with 3-inch hose. And your friction loss in 3-inch hose flowing 500 gallons per minute is about a third of what you're going to have in 2.5-inch hose. The fittings are the same. It's going to be a little bit of extra weight, but I think going to the 3-inch hose would be the way to go. And you'd build it up, and you'd put your manifold out, and that would be your ability to do 2 hose lines, right? And I think that works. If you do the friction loss calculations on everything you're doing, you know, we're gonna shoot to have a, you know, we want to have 100 psi here. You know, this is probably going to be between 200 and 300 feet because you got to go through somebody's apartment in this case, and then you go down the hallway, and then you go into the stair. So maybe it's even 300 feet. But this would all work, and of course your friction loss of 500 gallons per minute through this is probably not that great. Not that great. I think that waterway is 4 inches on the towers. I believe it is. So this would be a workaround with a compromise. Use your tower ladder to its advantage, and you know, get your water going as soon as possible. The third option, of course, is you got to build the whole thing all the way down. Don't forget, when you're putting the hose in the stairway and it's going, you're running the hose between the stringer, you know, there's going to be a lot of weight on that, so you got to tie it off. If it was me, I would tie it off at every fitting onto the stair handrails, and I think that would work.
Can I ask you a question from an engine company standpoint?
Yes.
If that brake would have been not on that horizontal from the pump to the riser, but on the riser itself, could we quickly talk about a workaround with that?
I think your workaround with that, if the brake was in the riser, would be to, again, go to your riser isolation valve, shut it off, put that riser out of service, and go and use your other risers.
Okay.
I think that's your answer there.
Okay. So the individual risers, the horizontal risers have the isolation valve is for the entire riser.
Yes. You're not going to have any way to like partly isolate a riser. You know, I have seen where risers have been damaged, and the contractor will come in and take a piece of pipe out, and they'll put a cap in, top and bottom, and they'll do a runaround with a piece of hose, you know, from hose valve to hose valve, and it at least keeps the riser in service. But that's not something we're going to do.
But nothing like a backflow preventer or anything like that? Okay.
No, we wouldn't go there. So I think that lays out some of the solutions here. Again, we know what happened. There's no doubt why it failed. We were fortunate in this case that while it was a dramatic looking incident, and it was actually a pretty minor incident from a fire loss standpoint, unfortunately the water damage did significant damage. I'm going to take a minute and see if anybody has any other questions. Okay, I think we're good, and we're going to move on. So again, tonight's presentation was to get beyond that fire department connection. We go out, more than 99 times out of 100, you tie to the FDC, you mitigate the incident, and you go. And I was going to talk about details of sprinkler systems, but I thought it would be much more helpful information for people to understand, okay, what if I pump into that FDC and it doesn't do what we want to do? What do we do then? And that's kind of what I'm going to talk about tonight. All right, so our first interface opportunity with the sprinkler system or the standpipe system is the FDC. Everybody's familiar with an FDC. This is a high-rise FDC, so you actually have the fire department connection and a fire pump test header next to it. All right, so to me, this is really important that we talk about this, and that is, why do we need to support the system? When I worked in Fairfax County in the fire marshal's office, we got a call to come out and look at a system, sprinkler building. It didn't put the fire out. There was more damage than they had expected. And we went out there, and the fire line tape was tied to the FDC, but nobody had ever connected to the FDC. They had never supported the sprinkler system. Had another fire I investigated in a jurisdiction very close by, a grocery store. This grocery store basically burned to the ground in the middle of the day. I think it was 3 o'clock in the afternoon. And that FDC was not supported until very late in the incident, really when it was too late, and collapse had already occurred in a part of the building. So it's important that we support it, and here's the reasons why. I don't know if anybody recognizes the picture on the screen. Let's go back to the screen. So that is the Kmart warehouse fire. That is a fully sprinklered building. Now, the details of it were that aerosol cans were exploding and basically shooting across the warehouse and past fire doors. But this is a fully sprinklered building, and this was a total loss. At the time, it was the highest dollar loss by value in the United This and I think this was 79, 80, 81, something like that. Fully sprinklered building, and there you go. It's off to the races. But in a non-high-rise, the standpipes must be charged because the FDC is the only way you're going to get your flow. In a non-high-rise building, the flows inside the building are calculated to just the sprinkler flow. You will not get the required standpipe flow until you pump into that connection. Now, in a high-rise building, that's different. A high-rise building is designed to give you the flows, which is 500 gallons a minute for the most remote standpipe and 250 gallons per minute for each additional standpipe. High-rises are designed to give you that all day long on their own without us ever even pumping into the FDC. That's what they're designed to do. Another thing, which accounts for that grocery store that burned down, accounts for that Fairfax building that burned, is the sprinkler design accounts for the fire department to use a certain amount of water and then support the system. So if the fire department rolls in and starts flowing more water than the design has accounted for, it pretty quickly robs water from the sprinkler system. And that's important. So supporting the system it's not an option, it's a must. The other thing is, we know that the sprinklers have operated, and we know that they're in the vicinity of the fire. They're already in place, whereas we've got to drag hose lines, do our thing, force doors. You know, the rescue squad's going to be in the way, and you're going to push them down, and all these different things. But we know those sprinklers have operated in the area that the fire actually is. So why not use them to our maximum advantage and support the system? There's other sprinkler systems, and Montgomery County is not awash with these super warehouses. Funny enough, Prince George's County is, Baltimore County is, Anne Arundel County is, and Howard County is. I think a lot of that is because they sit right along the 95 corridor. So they have these super huge warehouses. The systems in those warehouses are designed to flow anywhere from 1,200 to 2,000 gallons a minute. So we're talking about 1,200 to 2,000 gallons a minute, 100 gallons per minute per head to 150 gallons a minute per sprinkler head. So picture that. That's like a nozzle, and we're flowing, by design, we're flowing at least 12 of them. So you have 12 nozzles already in place, already above the fire. Oh, by the way, in an occupancy that historically has been a fireman killer. We don't run that many fires in warehouses, but if you look at the statistics, the firefighter deaths in warehouses is flipped based on evaluation of the number of calls we run. So supporting this system is super important. We can always put on a show for the public where we put up tower ladders and flow waters onto roofs, and the water never makes it to the fire. The fire department is actually pretty good at that. It looks pretty cool, but so many times those operations are ineffective. And I think everybody's been on that call where we put that in place, we pull everybody out, and we can't quite get to the fire. We do it for about 20 minutes, and then we're like, okay, we got to go in and put it out now. The fire at the Honda dealership in Burtonsville, we had a ladder truck that got a really good position, a tower ladder, 24, got a really good position. We were at a loading dock door, and they put that tower ladder right in the loading dock, and it was tires that were burning. That was the primary reason that fire went chaotic so quickly. The supply of tires, a fairly small supply of tires, but nonetheless. At one point, I think we were flowing 800, 1,000 gallons a minute with that thing, and we were getting zero conversion. And it was inside with the nozzle directed up, and we were getting almost no conversion. And eventually, we stayed at it, and eventually, we got conversion and we got the fire out. But we were kind of fortunate in that time because we could get that thing at a position, but flowing water on the roof in that case wasn't going to do anything. In my opinion, the most important thing is that when we build buildings today, the building code allows the building to be bigger, taller, and of lesser fire ratings once it's sprinklered. So the problem is, if the sprinkler system fails, we have a real problem on our hands, a genuine problem. And that's where you get these spectacular fires like the Kmart fire, spectacular fires like there was a cold storage warehouse in South Jersey a few years ago that burned that was just, made the national news. So if that sprinkler system fails, we have fewer safety nets in place. The building, again, it's going to be bigger between firewalls. It's going to be taller than it would have been allowed to be built without sprinklers. The fire ratings are going to be reduced because they're going to be able to use a different construction classification for the same size building. All those things combine that if the sprinklers don't control the fire, we have a genuine issue. So this is the why of it. So I want to talk about, so what do we do if we come and we go to use the FDC and it doesn't seem like we're getting any action out of it? What happens historically, 59% of the time that a sprinkler system does not control or extinguish a fire, it's because a valve was off. Another 17% of the time, it's because somebody turned a valve off too soon. They thought the fire was out, they didn't want the water damaged, they turned the valve off, and guess what? The fire came back, and by the time they got the valve back on, it was out of control. Up in the left-hand corner is a home for the elderly in Pennsylvania. A lot of investigation went into this. Adam St. John with the ATF investigated this when it happened. As far as we know, the FDC was never used in this case. And we're not going to Monday morning quarterback. Anybody could probably look this up. There were 4 fatalities and a number of significant injuries. It was a significant fire when they got there. The sprinkler system, it's about 99.9% sure the sprinkler system was turned off at the time of the fire. But the fire department connection was never used, and it wasn't in the best location. It met their code, but it was never used. And kind of what happened is they got there, they had a significant fire, and they focused on the life safety at the time, and maybe that was the way to go. But you got to figure if we could have eventually gotten that FDC charged before we had collapse, there's no way it's not going to make a difference. And certainly it's going to make a difference. And that's kind of what I want to talk about, the importance of using the FDC, and then we're going to talk a little bit about, well, what do you do if the valve is closed? Well, interestingly enough, I'm going to run a short little video, and this is at Wheaton Station, and if we could run this video real quick. FDC, or fire department connection, pretty obvious. This is the ball drip drain. This likely is not going to tell you where the sprinkler room is, but a better spot up would be the main drain. This will be 2 inches. The main drain will almost always be on the outside wall just behind the sprinkler room. In this case, the sprinkler room is behind here. Another telltale could be a water motor gong, but in this case, this building does not have one. They've kind of gone out of favor with electric alarms. All right, so 2/3 of all failures of sprinkler systems to control fires are due to valves being turned off that shouldn't be turned off. The fire department connection is designed in this system. It's a multi-zone system because we have a 2-story building. The fire department connection ties in here. You'll note there is no valve on the fire department connection line. So there could be an opportunity to visit the sprinkler room, find a valve closed, open it, and you're pumping into the FDC, would supply the system. In a single zone system, the fire department connection is always going to tie above this control valve. So if this control valve was closed, you could simply pump into the FDC and circumvent this closed valve. But in a multi-zone system, the FDC is going to tie into the header, and you may need to come and open valves. All right, so we're back. Video should have been straightforward. What's important to note there is you may have to find the sprinkler room. The good thing is the newer code that's being enforced typically requires the sprinkler room to have an outside door. So that makes our life a little bit easier. But finding that main drain is the telltale where the sprinkler room is going to be. That's almost always on the wall immediately adjacent to the sprinkler room. So that's going to be important. On a single zone wet system, the FDC is going to tie in past the valve. So if you have a single zone wet system, and you typically know this by doing some pre-planning or by looking at the size of your building, if it's a 1-story building and less than 52,000 square feet, it usually will have one zone. If that's the case, tying into the FDC is going to push water in beyond the valve. So if the valve is closed, you won't have to do anything. You'll still pump into the system and support the system. On the other hand, if you have a multi-zone system, that's where you would need to find the sprinkler room and potentially open the valve that's closed. Or if it's a floor control valve, you might have to go to the floor and open up that valve. So I hope I was clear in the video that we can work and we can impact the outcome by correcting a wrong, opening up a system that shouldn't have been closed. There are going to be times where systems are shut down. They are required to notify ECC, and they do have a record of that. And if the system is shut down, we should get something on the computer that tells us there's a system shut down. My opinion is that no matter why the valve is off, if we don't know why it's off specifically, you open the valve up. If it improves the situation, great. If it doesn't, well, then you shut the valve again. It's not the end of the world. You've already got a case where we have a sprinklered building and the sprinklers are not controlling the fire, so I don't see any damage in that. So the other thing I wanted to talk about is kind of the modern construction that we're presented with. Building on the left is basically you look at it and you're like, okay, how many stories I got? 1, 2, 3, 4, 5 stories. Building on the right, 1, 2, 3, 4, okay, 5 stories on one side, 4 on the other. Well, and you think, okay, these are the same building, right? Where they're not. They're not the same building. They're actually markedly different. The building on the left is all concrete and steel construction. Light gauge steel, but steel nonetheless. And it is an apartment building being built in Kensington on Metropolitan Avenue. The lower floor is going to be used for retail, stores and shops and restaurants. The upper floors are apartments for the elderly. But you look at the one on the right, and it looks virtually identical. Well, what's the difference? The one on the left is fully sprinklered and non-combustible construction. The one on the right has 1 story of concrete construction, and then above it is wood construction. You can't tell from looking at it. If you saw it being built, you'd know, but right now it's pretty hard to tell. it's going to present you with an entirely different set of scenarios to manage. You're going to have combustible concealed spaces. The one on the right happens to be a fully sprinklered building, which means that it should have sprinklers in the concealed spaces, or it'll be designed that if a fire starts in a concealed space, like a floor ceiling space, it's been fire stopped so that there's not substantial spread. But nonetheless, the chances of a fire behind the drywall on the building on the left are pretty remote, but the chances of a fire behind the drywall on the building on the right are fairly substantial. But when you roll up to this at 3 o'clock in the morning, they look identical. They look identical. So this technique is called platform construction, where we try to get as many mixed uses as possible. Why? Because the value of the land and the property is so expensive, they want to maximize their investment. And the county loves this. The county loves the whole, work, play, sleep, eat, kind of in a small area. Reduce the traffic. That's kind of the county's master plan, is to go to that. Well, what that means is more densely built things with more use groups built into them. So another question I get quite a bit is, what's the difference between an NFPA 13 system, which we call a fully sprinklered building, versus an NFPA 13R sprinkler? This building here, I don't know what sprinkler system it's getting, but it has a fairly small footprint. It is 4 stories on top of the concrete. You can obviously see the 4 stories on top of the concrete is wood. It will not surprise me if this is an NFPA 13R system, because one difference the code delineates is the NFPA 13 system, you can build the building bigger without firewalls. You can't do that with an NFPA 13R system. But this is a fairly small footprint. This is on Knowles in Kensington. And this is also going to be an apartment for the elderly. So now all of a sudden in Kensington, in Station 5's first due, you have 2 apartments going in locations that virtually had no occupancy at the time, and we've really increased the density. So my anticipation is, at the very least, 5's ambulance is going to get a little bit more busy. There's no doubt. So what's the difference between an NFPA 13 system and an NFPA 13R system? The big difference is that an NFPA 13R system, you do not have to sprinkler the concealed spaces. It is a life safety system. And what the code did years ago, and you can't fault them for this, because they were trying to design systems that would be economical so the building industry would stop fighting them on putting sprinklers in. And what they did, let me see if I can get my pointer to come up, is they looked at these numbers. And what these numbers represent are civilian deaths versus the civilian percentage of deaths in fires. And then they took all these numbers and they said, okay, we got to give up something. And they pretty much drew a line and they said, okay, we're going to make sure that the areas where fires occur that cause death and injuries, they're going to get protected with sprinklers. But the areas that are less frequent for fires, and more importantly, less frequent for deaths and injuries, like your garage or carport, an outside stairway, a lobby, an attic. So look, during this time that they evaluated this for 5 fire years, attic or roof ceiling assemblies, they only had 3 civilian deaths. So you know what? Sprinklering an attic is expensive. You can't do it with a normal sprinkler system. You've got to put in a dry system or some other accommodation, or you got to heat the attic. Well, heating the attic, that goes against the energy code, which is, very forceful right now in our building code industry. So the codes basically said, you know what? We're going to design a system that from a life safety standpoint is like 98% effective. And that's what they did. And that's what we have to deal with. So I'm going to scroll back through here. Bear with me one second. We're going to go to this back to this slide. Whoops, that's not what I want. Hang on a second. Okay, so let's go back and look at our wood building. So if we were to roll up to this building, the floor ceiling space across here would not be sprinklered. It would not have sprinklers. The floor ceiling space here would not have sprinklers, and here, and here, and if we had a peaked roof and an attic, we would not have sprinklers there. So the 13R sprinklers have been very effective. Most of the time a single sprinkler head, sometimes two sprinkler heads activate. If the fire starts in an area that's protected, it's probably going to be no big deal for us. On the other hand, if the fire starts in an area that's not protected, then we're going to be behind the 8 ball. And we have had situations where we've burned attics off of these buildings. I investigated a fire some years ago. It was when 13R had not actually been put in place, and the contractor and owner had negotiated with the local fire marshal a system that wound up being very similar to a 13R system. And the fire started on the exterior of the building. It was vinyl siding. It burned up, burned in the attic, burned down. It burned down nearly the whole complex. It was a fully occupied building, and in the end, it got a lot of news attention. But in the end, there wasn't a single civilian death or injury. So you'd have to say that the sprinklers did exactly what they were designed to do. Protect life. Property protection is important, but in this case, it's going to be a secondary benefit of a 13R system. So I hope I identified the difference between those two systems. From the outside, you will not be able to tell what kind of system it is. You will need to go and, when the building is at this point in construction, that's the time to go interface with the contractor, get them to walk you around, find out what kind of system is going in, and then put it in our pre-plans so that we know, because it is an entirely different animal that we will have to deal with. And this again, this is a 5-story. For all effects, the code looks at this as, well, it's 4 stories of wood on top of concrete, so we're going to treat it like a 4-story building. But I mean, you can look at it. For us, it's a 5-story building. My semi-old self is going to have to potentially walk up 5 stories, even though the code treated it like a 4-story building. So that's kind of what I had tonight. I want to leave enough time at the end to answer any questions. I didn't want to get into the weeds talking about how a sprinkler system is designed. Everybody knows kind of how it operates. All the different systems, dry systems, wet systems, pre-action systems, double interlocked pre-action systems. I think it's much more important for us to learn and know how to interact with the system and how to correct a wrong that might be happening to make our lives a little bit easier. So we'll give it a minute or so. I think we have some questions coming in.
The only question is, can the chief elaborate on the Wheaton's getting a new pumper statement?
What? Did I say that?
Yes, you did. I made note as well, chief.
No, we're not. We're not. I just wanted to slip that in. I was making sure that everybody was awake.
Everybody was.
All right. We don't have any other questions?
Not right now, no, sir.
All right. Then that's all I've got this evening. Thank you so much.
Chief, thank you again for coming back, and each time your presentations are so informative. As a reminder, if you have questions, you can email myself, you can email Chief Davis, Chief Dempsey. All of us will get back to you. Our next Boss Talk episode will be June the 2nd. We're going to try to work from Company 16 to do that. And then our next challenge in the street is June 29th. Captain Randall will do a presentation on our UTVs. All right, thank you. Have a good evening.